everyone. We're going to determine whether our series converges or diverges. So the first thing we're going to do is see if our series converges absolutely. And if we use the limit comparison test with the sum of n equals 2 to infinity of 1 divided by n, we know that this is divergent. So if we get a c that's a finite number and that our c is greater than 0, then both series converge or diverge. So let's test that first. So if we get a finite number and c is greater than 0, our series will diverge. So we're going to let a sub n equal 1 divided by ln of n, and we're dividing by b sub n, which equals 1 divided by n. And we take the limit as n approaches infinity of 1 divided by ln of n, and then just multiply by the reciprocal. Now when you do the limit as n approaches infinity of n divided by ln of n, this is just going to go off to an infinity, which is not a finite number. So even though this diverges, it doesn't mean this diverges, but it also does mean that our series doesn't converge absolutely. All right, now let's use the alternating series test. So basically we just have to do these checkpoints here, and let's look at that. Let's call this, let this be u sub n equals 1 divided by ln of n, and this is positive. So for n is greater than or equal to 2. So it checks number 1. So it has to also satisfy condition 1 and 2. So let's look at number 2. We know that n plus 1 is greater than n. Therefore, ln of n plus 1 is greater than ln of n. Therefore, 1 divided by ln of n plus n is less than 1 divided by ln of n, because this is your bigger denominator. So it satisfies condition 1. Now let's take the limit. Take the limit as n approaches infinity, and we're going to have 1 divided by ln of n, and as the denominator goes off to infinity, this equals 0. So our series converges. Equals 0 here. It's just not absolutely convergent. Thank you. Have a nice day. Bye-bye.